Hello friends, welcome to my YouTube channel. Myself Gunjan Malviya from MTech IT 2K21 batch. In this video, we are going to study interpolation and its type. Before starting the video, I would like to thank Dr. Shaligram Prajapat sir for guiding me in the subject of numerical analysis and design. Now let's get back to the video. Interpolation is the technique of estimating the value of a function for any intermediate values of the independent variable, while the process of computing the value of the function outside the given range is called extrapolation. Type of interpolation: Newton-Gregory forward interpolation formula, Newton-Gregory backward interpolation formula, Lagrange's interpolation formula, Newton's divided difference interpolation formula. First, Newton's Gregory forward interpolation formula. This formula is particularly useful for interpolating the values of f of x near the beginning of the set of values given. H is called the interval of difference and u equals to x minus a by h. Here a is the first term. Second, Newton's Gregory backward interpolation formula. This formula is useful when the value of f of x is required near the end of the table. H is called the interval of difference and u is equals to x minus a n by h. Here a n is the last term. Third method, Lagrange's interpolation formula. Lagrange's interpolation formula finds a polynomial called Lagrange's polynomial that takes on certain values at an arbitrary point. It is an nth degree polynomial expression to the function f of x. The interpolation method is used to find the new data points within the range of a discrete set of known data points, such as f of x equals to x minus x1, x minus x2 up to x minus xn divided by x0 minus x1, x0 minus x2, x0 minus xn into y0 plus x minus x0 skipping x1, x minus x2 up to x minus xn divided by x1 minus x0, x1 minus x2 up to x1 minus xn into y1 and till this method continues till y of n. Fourth method, Newton's divided difference interpolation formula. It is an interpolation technique used when the interval difference is not same for all sequence of values. Suppose f of x0, f of x1, f of x2 up to f of xn be the n plus 1 values of the function y is equals to f of x, corresponding to the arguments x equals to x0, x1 up to xn, where interval difference are not same. Then the first divided difference is given by f of x0, x1 is equals to f of x1 minus f of x0 divided by x1 minus x0. Simpson's 1 by 3 rule. Simpson's 1 by 3 rule is an extension of the trapezoidal rule in which the integrand is approximated by second order polynomial. Simpson's rule can be derived from various ways using Newton's divided difference polynomial, Lagrange's polynomial and the method of coefficients. Simpson's 1 by 3 rule is defined by integrating from a to b f of x dx is equals to h by 3 y0 plus y1 starting term and the end term plus 4 into sum of all the odd terms plus 2 into sum of all even terms. This rule is known as Simpson's third rule, one third rule. Simpson's 3 by 8 rule. Simpson's 3 by 8 rule. Another method of numerical integration is called Simpson's 3 by 8 rule. It is completely based on the cubic interpolation rather than the quadratic interpolation. Simpson's 3 by 8 or 3-8 rule is given by integration from a to b f of x dx is equals to 3h by 8 from first term to nth term, that is y0 plus yn plus 3 into sum of all the terms up to n minus 1 except multiple of 3 plus 2 into sum of multiple of 3 terms. This rule is more accurate than the standard method as it uses one more functional value for 3 by 8 rule. The composite Simpson's 3 by 8 rule also exists, which is similar to the generalized form. The 3 by 8 rule is known as Simpson's second rule of integration. Now let's move on to the trapezoidal rule formula. We apply the trapezoidal rule formula to solve a definite integral by calculating the area under a curve by dividing the total area into little trapezoids rather than rectangles. This rule is used for approximating the definite integrals where it uses the linear approximation of the function. The trapezoidal rule takes the average of the left and the right sum. Let fy is equals to f of x be continuous on a comma b. We divide the interval ab into n equal subintervals, each of width h is equal to b minus a by n, such that a equals to x0 smaller than x1 smaller than x2 smaller than x3 up to x smaller than xn equals to b. Area is equals to h by 2 y naught plus 2 into sum of all the remaining terms up to n minus 1 plus yn. Thank you.